The kind of unique thing with ESCO is that most of us are wrench turners. So I always say that we're wrench turners and writers. And so I myself spent about 20 years out in the field. I was a mobile engineer. I did commercial refrigeration. I started in a family-owned business that was refrigeration and residential HVAC. In that late 90s and early 2000s, we had a lot of refrigerant transitions that residential HVAC may not have seen, may not have recognized. As we were moving away from our CFC refrigerants and even some of those HFCs, we've seen a lot of alternative refrigerants for those systems. We had to look at different refrigerants and understand the capabilities of refrigerants. In residential air conditioning and light commercial air conditioning, we really had a couple primary refrigerants that we worked with. R22, everyone comfortable with R22? R410A, right? That's been our primary medium temp application refrigerants for a very, very long time. We've gotten very comfortable with those. And we're all a little hesitant on change. That's just kind of the nature of the beast. Residential and light commercial air conditioning hasn't really faced that except for what refrigerant? R22, right? Price of the refrigerant goes up because we phased out R22, so we had alternative refrigerants to replace that. So you got things like 422s and 407s, right? There's different refrigerants that you can use for replacing those in existing systems. But we didn't have any new refrigerants in new systems, right? We just made a quick transition from R22 into R410A. We did that in the 1990s. Well, a lot of things have changed since then, and they're changing very quickly right now. So I refer to this next decade as a decade of transition. It's a decade of development for residential applications. We got to prepare for these transitions because we're going to have to make sure that our tools are able to work on some of the stuff. We have to make sure that we know what looks different. Are the pressures the same? You're going to have two primary refrigerants replacing R410A. Did you know that? So let's talk about these different topics. Let's talk about what transition is going on, because a lot of people don't even know that we're in the middle of a transition. It's all based on global warming potential. We're going to talk about the standards and the regulatory updates that dictate all this, that actually gives direction for it. We're going to go over what the environmental considerations are. We're going to talk about flammability, and we're going to talk about what's happening in the industry, why it's important to know these, and will it affect the way we install and service equipment? Because it kind of does, unless you're already doing best practices, and it really won't make a huge difference. There's just going to be some nuance. Let's talk about this whole phase down, phase out thing. If we look back in history at refrigerants, we started using CFC, chlorofluorocarbon refrigerants, in the 1920s. Because before that, all we had was real toxic stuff or real flammable stuff or real high operating pressure stuff like CO2. All of those early refrigerants actually had ozone depleting potential and they had global warming potential. And we measured both of them, but we made the biggest changes with the CFCs. And then later, the HCFCs, like R22. A lot of people don't know, we started phasing out, not down, of those HCFCs. A lot of people talk about R22 and go, well, we still use R22. Well, you don't use it in new systems. You actually haven't seen it for 4 years almost in new systems. It was phased out 100%. So we started a schedule. All the way back in 2013, we reduced, and we started working our way down to by the time we got to 2020, there was no newly manufactured refrigerants. The goal was that those refrigerants that were out there, those R22s, they would actually come back. They would be reclaimed and then recovered or recycled. That was those 3 R's that we learned in our EPA class. That was the goal. We were supposed to bring those old refrigerants back and they get cleaned up and they can put back into the industry. Then you have this other thing called the phase down. The phase down doesn't completely eliminate it, but it absolutely reduces it. The refrigerants that you are comfortable with right now, the refrigerants, I can tell you the ones I'm comfortable with. I'm comfortable with R410A. I'm comfortable with R404, which is my low temp refrigerant, and I'm comfortable with 134A. That's my medium temp refrigerant. It's also the refrigerant that we use in a lot of our automotive, because we are currently in a phase down of HFC refrigerants, hydrofluorocarbon refrigerants, R410A, R404, R134A. There's a whole bunch of them. I'll show you quite a few of them. They're on their way down right now. Started with that 10% reduction. So we have other refrigerants out there like that HFO, hydrofluoroolefin. That is a modified HFC. So things like 1234YF, that's an HFO refrigerant. It has a really low global warming potential refrigerant base to it. So we're going to see a lot of that. And we're also going to see HCs. Anyone ever heard of hydrocarbons? You probably sit on 20 or 30 pounds of it in your vehicle every day and you don't realize it. You've got 20 pounds of it sitting in a cylinder outside of your back of your house that we use an electronic ignition device to intentionally ignite it. It's called propane. If we take out the sulfur dioxide that is in it, the odorant, you end up with R290, hydrocarbon, purified propane. And we're seeing a lot of that. Right? So we're not talking about using hydrocarbons in residential at all. And that's the big thing we have to talk about, because there are misperceptions in the industry when we start talking about these things like flammable. You and I think of flammable as if I open my acetylene tank and I strike it and it lights, that's called flammable. Well, there's actually great big differences in what flammability actually is, and I'm going to show you what some of those are. And so there's a misperception in the industry that we're using hydrocarbons in these new mildly flammable refrigerants, and we actually don't, not in residential and commercial applications. We only see it in the commercial refrigeration sector in R290 and in R600, right? R600 is isobutane. If you bought a refrigerator in the last 7 or 8 years, a brand new refrigerator, it probably actually has R600, isobutane in it. Same kind of butane we use in lighters. Residential and light commercial HVAC, we've been fortunate for about 3 decades. We haven't seen a ton of change, and you're going to see it. Some of us who've been in the business for a while, we're not going to like this. We're going to resist this change. Here's what this reduction looks like. So this was actually set in play by the Kigali Amendment to the Montreal Protocol. All goes back to the Clean Air Act. The Clean Air Act is what started the whole 608. Anyone that carries a 608 license, that is Section 608 of the Clean Air Act. That's where that comes from. It establishes the way we handle refrigerant. But what happened in the middle of that, there was another act called the AIM Act, American Innovation and Manufacturing Act. It's really what has ignited a surge of technology in all industry. It's ignited a lot of development of the United States. A lot of infrastructure is all based out of the AIM Act. But in that AIM Act was another little piece that did get signed by Trump. A lot of us think he probably didn't even recognize it because it was such a small piece of that AIM Act. But what it was the exact same phase down schedule that was proposed in the Kigali Amendment. So not only do we have the AIM Act saying we're getting rid of HFCs, we've also got the Kigali Amendment, an international treaty going, you're getting rid of it. So we have two things going against this right now. You have Congress, it's an act of Congress, as well as an international treaty saying we have to get rid of HFC, hydrofluorocarbon refrigerants. By 2036, we will have reduced the manufacturing of all HFC refrigerants by 85%. This was established in 2015, so it didn't start yesterday. It didn't start in 2022. It actually was approved in 2015, and it established that in 2022 we were going to start this phase down, so we did. So we reduced the total manufacturing of HFCs based on their global warming potential by 10%. When we hit January 1st of 2024, we're going to add the big slide. We're going to add 30% on top of that. As a contractor, this is going to hurt. It just is. Last year hurt. We all know that. So it's going to hurt, and we are all aware of that. The manufacturers are hurting more than anyone because they have to come up with a refrigerant to put in new equipment. And if we don't recover what's out there, we are also going to affect this. Because remember, this is by EPA looking at that, they're going, okay, we're going to reduce the amount of this newly manufactured refrigerant, but we are assuming that quite a bit of it's coming back from the field. And we'll clean that up and we'll put that back into service again. Does that happen regularly? Do you bring back as much refrigerant as you buy? I know the answer to that. Well, we're starting to see it already, that the prices of used refrigerant are actually going to start climbing, especially after January 1st of 2024. Once the prices of HFCs go up again, the value of used refrigerant is going to go up. So it's going to be even more important to reclaim refrigerant and bring it into Johnstone Supply. So what does it all mean? All right, there's 2022 was that 10%, 2024 is the 40. That's the hard. We're adding 30 on top of it. We're going to add another 30 in 2029. So by the time 2029 gets here, there's only going to be 30% of the available HFCs being manufactured is what there was a year ago. And so now we have to look at, okay, not a big deal. What does that tell me? It tells me we need to find some different refrigerant. And so that's what actually happened. So we did that. We started looking at other refrigerants. We've been doing it for a long time. And so due to the AIM Act, as well as the Kigali Amendment, we are phasing down refrigerant. So this is what's coming, is these changes into refrigerant. It's based on global warming potential. If we looked at the ozone depleting potential of refrigerant, it was how much chlorine was in it. How many ozone molecules did it destroy when it got in the atmosphere? That's where the ozone depleting potential number comes from. Global warming, how much heat can it hold in to the planet? Global warming potential is literally how much heat does this trap in the atmosphere, right? Whether you believe in global warming potential or not, that's entirely up to you. We are making changes to the way we look at global warming and the impact that we make on that. All refrigerants have a GWP, a global warming potential. That is its ability to trap heat in the atmosphere in comparison to CO2. We have refrigerants right now, particularly our HFCs, that have very high global warming potential to them. Some of them actually went up. When we went from R22 to R410A, ozone depleting potential went down to 0 because we took the chlorine out, but our global warming potential actually went up. It wasn't until this last decade or 2 decades really that we started focusing on global warming potential. So we now have to look at all refrigerants based on the global warming potential. I have R410A with a global warming potential of 2088. 2088 times the capability of trapping in heat is what CO2 does when it gets in the atmosphere. We have things like that 1234YF. That's one of our newer HFO refrigerants. It has a global warming potential that's shown at around 1. Theoretically and mathematically, it would take 2,088 pounds of 1234YF to do the same impact to global warming that 1 pound of R410A does. All of this whole global warming potential, we're going to reduce these HFCs based on a global warming potential. That simply means that everything with the highest global, think about it. If something is bad, and some things are worse than others, what's the first things that are going to go away? The worst things, right? Every refrigerant that has a high global warming potential is going away the fastest. R404, that was a dominant low temp refrigerant for my days. Most of the low temp racks that I worked on in grocery stores were 404 racks. It was a great refrigerant for low temp. You can't hardly get equipment with 404 in it today. Even though it's the same HFC, it's under the same phase down because it has such a high, it's almost twice as much as R410A. Started its slide. The manufacturers real quick went, we gotta do something besides 404 because it's at the top of the game, so it's going to be going away the fastest. And it has. In new equipment, 404 is nowhere near as common as it used to. You'd go get a Manitowoc ice machine. I was a Manitowoc dealer for years. Every one of them had 404 in them. Today, a lot of them are using R290, purified propane, in the commercial ice machines. A lot of people don't know that, but that's what we're doing because that propane has a very, very low global warming potential. Is it more flammable? Yeah. How flammable is the gasoline underneath the seat in your van? But we control it and we understand it. How flammable is the natural gas and the propane going through the gas furnace? Pretty flammable, but we use things to control it and to understand it and educate on it. And that's all we're going to do. We're just going to educate on this stuff, and we're going to learn to be comfortable with new refrigerants because we have to. That's all. We absolutely have to. So that's what's happening. All HFC refrigerants are going away, and they're doing it in a big slide, and they will pretty well be gone by 2036, which means things are transitioning right now. If you think about it, when change comes, you do one of two things. You embrace it and you excel, or you deny it and you fall to the wayside. We're all going to do that together. So that slide started back with the Kigali Amendment when it was adopted in 2016, and we're going to do a bunch of phase down. So this is the United Nations. This is not just us. This is the world is doing this exact same thing, right? A lot of the world didn't even go to R410A in the 90s. A lot of them went to R32. When we planned the phase out of CFCs like R12, like R502, when we started that phase down, we had a plan and we had overlap. We phased down HFCs. We started it in 1990. We were done in 1999. But what happened is we had already introduced, just in that time frame, we introduced not one generation of refrigerants, these HCFCs. Shortly after, we introduced an entire another generation of refrigerants called HFCs. As we phase out these HFCs, we didn't have a lot of overlap. We have already begun the phase down, and we didn't have anything in play to balance it out. The refrigerants that we know, 134A, HFC, going away. 407, HFC, going away. 422, 410A, R32. R410A has 2 refrigerants in it. Did you know that? It is 50% R32, which is an A2L. It's mildly flammable, and 50% R125. It's a flame suppressant. We use it in a lot of commercial commercial kitchen flame suppression systems. It's a flame retardant. In the 90s, when we were going away from R22, we actually introduced R32 into the world. That thing that we called Puron back in the 90s, that R410A, that was a blend. That was a new thing. But it was a blend of Daikin's R32 and a blend of 125 so that it wasn't flammable at all. Well, I say that. I shouldn't say that because there is a slight flammability to it. All refrigerants have a slight flammability in the right circumstance with the right amount of heat and the right amount of compression. But the United States was not ready to make that transition. Our building code said flammable refrigerants. No one wants that. Let's take something like R32, let's mix a flame retardant in it, we'll call it something new, and that's the reason we actually flip the jug upside down for R410A and we don't for R22. R22 is a single constituent refrigerant. Whatever's in that tank, if it's on the top, it's in vapor, if it's on the bottom, it's on liquid. R410A, there's a little bit of glide in between that because they boil at slightly different temperatures, so we should flip the tank upside down for it. Remember that, because we're going to come back to it when we talk about these two new refrigerants, kind of new, coming to the market. R32, the basis for half of the basis for R410A, it's a hydrofluorocarbon. It is subject to the exact same slide that everything else is, right? And people don't talk about that, especially the manufacturers, but we have to talk about that. We have to be aware of what this means. But it is a much lower global warming potential refrigerant than R410A. That R125 we put in on top of 32 to keep it from having any flammability, it wasn't the greatest. It had very, very, very high global warming potential. So we take that out, we get R32, and we have a much lower global warming potential. So we're going to have that to work with for a while, but the others, higher global warming potential, they're just about shot. So we're going to see two primary refrigerants in the residential and light commercial industry. Even some of our VRV stuff, you're going to see this exact same transition if you work on any of that. You're going to see that R32. Of course, Daikin's going to continue using it. They've made it this whole time. That's their primary refrigerant. They wanted us to go to it in the 1990s, but we weren't prepared as an industry. So you're going to see R32, which just means we've taken out the flame deterrent, 125. We took that out of it, and you have R32. And then we're going to do something else, which a lot of the manufacturers are going to. Has anyone heard of 454B? It's R32. Remember that 1234YF that we talked about going into our vehicles, that HFO? So it's a blend of R32 and 1234YF. So there's three different generations of 454, A, B, and C. They're different blends of 32 and 1234YF. So you're really going to be working with 32, even if you're not told it. You're already working with R32 and you weren't told it. You're either going to be working with a single constituent refrigerant, R32, which means when we're charging it, it can be in the vertical position or it can be upside down. Gas on one side, it's liquid on the other. Or you'll be working with R454B, which is simply going to be more like R410A. When we're charging it, we want liquid, we get liquid out of the tank. We flip it upside down. It's really primary differences. Refrigerant pressures are going to be similar. They're not far off. It's not like when we went from R22 to R410A. What did we all hear when R410A came? Oh, it was the #1 complaint. Oh, them pressures, they're going sky high. We're going from 250 to 400 pounds of pressure on this high side of this system on a hot summer day. Well, we're actually not going to see that. We're going to see the pressures being very, very similar to R410A, but there's some very key differences. And that's that flammability, or mildly flammable is what we should actually say. So that's your two refrigerants. R32 has actually been out on the market for a long time. Next time you go to Costco, walk through the aisle that has the window air conditioners and the portable air conditioners. What refrigerant would you expect to find in a window air conditioner? What have you ran into in the past, or have you? It was 410A. For the last couple of years, they have all been R32. So there's some things, so the EPA, we're gonna see more of the EPA involved in what we do because they help determine what refrigerants are able to be used in certain pieces of equipment. So the EPA has this thing called the Significant New Alternatives Program, and what they do is they look at refrigerants and they go, hey, if this refrigerant worked in this piece of equipment, what refrigerants are going to work good in that piece of equipment with a new refrigerant? We spend a lot of time talking about the SNAP policy and what is happening for all refrigerants, wherever you work. So this is not just for residential commercial air conditioning, this is refrigeration, foam blowing, this is like everything. So they tell us what ones work. And so what we have seen is we didn't see a lot of action from the SNAP for a couple of decades. We did back when we were moving away from the R22 stuff and all of our R12s, they were very involved. Well, over the last couple of years, they spent a lot of time helping us understand what refrigerants will work and how much refrigerant can go in a system before it becomes something to be concerned with. So they're the ones that kind of set the standards for how much refrigerant of, say, like R290 can go in equipment. So they'll take a piece of equipment, and if you go to the EPA EPA snap, you'll see all of this. You'll see like rows and rows. This is what we do, is whenever a new policy comes out, we just sit around and read. And so what we do is we break it down and we show you, like say commercial ice machines, new commercial ice machines. Well, here's the refrigerants that can go in it. And then it's kind of up to the manufacturer to decide, all right, which one am I going with? This is what I can use. I'll just go by this and we'll make decisions. So we do that for everything. SNAP 26 was a very important one. They proposed these limitations on refrigerants and equipment. When we look at it, we got a couple different things. We got EPA going, all right, we can use these refrigerants as replacements for these. And then we've also got ASHRAE going, but we got to be safe while we're doing it. So maybe we'll set some limitations on how much of the refrigerant can be used in a system. We want to make sure that you're working safely with whatever these refrigerants. The EPA says we can use this. ASHRAE says, well, how much of that can we use? What's the limitations on that? Has anyone looked at what it's going to look like for contractors and technicians? And so they set the standard. And we're going to talk about a few of these. If you're ever interested on where a lot of our content comes from, ASHRAE really is a big component of that. 15.2 is very, very important for what we're doing on a daily basis. What we really have, and this goes for all gases, because a refrigerant's a gas. It goes from a liquid into a vapor in a gas state. It's a gas. So ASHRAE looks at everything and they go, all right, let's put them in groups. Let's make this easier. Let's put it in groups so we know what we're working with. And so we have these things called higher flammability, lower, and then no flame propagation. What propagation simply means is if it lights, is it going to actually expand? That's the biggest difference that we're going to see. We actually have used this for a long time, but we just recently added these 2 L's. And so we also have these things called toxicity, because a lot of our ammonia that you mentioned earlier, that's a pretty toxic refrigerant, pretty toxic chemical. So we rate all gases based on how flammable are they and how toxic are they. The goal is to be an A1. That means it has very low toxicity and it has very low flammability. That's the things we're comfortable with. That's our R410A. It's even R22, 134. It's a lot of these that we know are down here in this A1. That's where we'd like to be. That's the safest place to be. Here's the problem. A lot of times when our global warming potential goes down, the flammability actually goes up. It's a handoff. It's the reason we didn't go with R32 in the 90s. We're going to see a lot of this stuff. Has anyone heard of A2L refrigerants? That's what we're hearing most of. We're not hearing about 1234YF that's in the cars. We're not hearing about 1234YF that's getting mixed with R32 to make 454, but we should, because those are the A2Ls, right? So A2L has a little bit more ignition possibility than what the A1s that we're comfortable with, but it's not a ton. And then you have A2s, and then you have the A3s, propane, isobutane, these very flammable stuff. We are moving from A1 refrigerants in most of our industries into things like A2Ls and A3s, which means we need some training from the scientific view and maybe even from the field view. In those classes, they have different burning velocities, and that affects what we look at as the A2Ls and the A3s. And so what you'll see is when we put it into a confined space, we can measure what that expansion, that flammable movement looks like, that propagation. Some of our A1s, takes a lot to get them to do anything. Our A3s doesn't take very much. It's these A2s and A2Ls that are in between, which makes us think, okay, I always thought a refrigerant was non-flammable or it was flammable. I wasn't taught that there's things in between. And that's what we're here today, is to understand those things in between, because they're very much in between. So in a lab, when we look at these 2Ls, we can see expansion. If I put a bunch of propane in a cylinder and I turn on a direct spark ignition, that sucker's gonna light. That's what it does. Some of these A2Ls will as well. Maybe not as much, maybe nowhere near as much, but they do. Even our A1s, our R410A, will actually light in the right circumstance. You're going to see, if you go to Costco and you've got window air conditioners and they've got R32 in them, you're going to see a new label that you're not used to seeing. The thing that we have to be very aware of as contractors and as technicians is our consumer. Think about it. If you're a consumer and your contractor shows up with a piece of equipment and it has these on it, are you going to question that piece of equipment? What if you don't have the answer? That could be a difficult conversation. So the point is to make sure that you do have the answer. And it's a very simple answer. And it's a very comfortable answer that you can relay to your consumer. Hey, our industry is changing. Because the first thing they're going to think of is, he's trying to sell me a flammable piece of equipment. I better go get a different type of equipment. You go, well, we have to understand that the entire industry is changing. Everyone is changing. Everyone is going to be seeing these. So now we just go, okay, there are different classifications of flammable gases, and some have a little bit of flammability, not like things that you're used to like gasoline or propane or anything like that, but there's a little bit to that. And so we have to put a decal on it. So if it's got an A2L in it, you're going to see this, and so we have to be aware of what that means to us, and to be able to go, all equipment that has an A2L on it is going to have these kind of stickers. And so now it becomes a consumer education as well as a contractor education. Consumer has to be educated as well as us. But there are some things that we have to be aware of. There were some things with our A1 that we considered best practices that should have been required practices, but they weren't. Technically, best practices wise, proper installation, they should have been, but they weren't. If we talk about things using nitrogen while we're working, that actually should be required. But because things like R22 and some of our mineral oil-based refrigerants, it wasn't even in the installation manuals at the time, we always looked at that as a best practice and not a required practice. We now know better. We now know that we flow nitrogen anytime that we're brazing, so we don't oxidize the inside of the copper. That's a known practice. So you will start seeing in the installation manuals of every manufacturer with a piece of A2L equipment, that will now show as a required practice, not just a best practice. Proper evacuation, as well as leak testing and pressure testing the unit. You'll see these in the installation manuals. Those will look different from what you've seen, because we all read every installation manual front page to back, as we should. So when you see these, you'll know why it's in there now. Some systems are going to have some pressure relief valves that look different than they had in the past. If we have a tank of R410A, if the refrigerant cylinder itself or the outdoor unit itself gets to an excess amount of pressure, it has a relief valve on it. You've all seen the little disc on the top of a tank of refrigerant? That's a pressure relief valve. If it gets too high a pressure, it opens and all of the refrigerant dumps out of that cylinder. Our A2Ls are going to move to a pressure relieving device so that if the tank gets too hot, if the system gets too much pressure on it, it will release, but it will only release to the point that it can get back down to a safe operating pressure. It's not going to dump all the refrigerant like it would have in the past. Yeah, and it does. I mean, we don't see tanks ruptured very often. We don't see systems with high pressure relief valves ruptured very often. Sometimes in commercial refrigeration applications, if we say we lose an entire condenser fan motor circuit and our condenser's sitting up there rocking around 800, 900 PSI and the thing goes, we can't do this. It might open a pressure relief valve and get the system pressure back down to zero, gets the low side down low enough that the low pressure system shuts it off. So those systems are out there if you didn't know. Well, a lot of residential systems actually have it built into the system as well, but we never see them because they typically don't get that high. But you will see that device changing on new equipment, and it might just look a little bit different. If you see one, you'll know, if there happened to be a catastrophic failure of this system, it's going to release refrigerant until it gets down to safe operating pressure. Then it's going to be low on charge. But at least it's not dumping all the charge out of it. So that one does change. Here's the one that the industry is not educated on at all at this point, I would say. I won't say at all. I say fractionally educated, because there's only a fraction of the industry that's even aware of this. And it's already starting to hit markets. We haven't seen it in a lot of residential split systems, but you're going to over the next few months. We're going to now require mitigation on a system. And that gets scary to people. Like, oh my gosh, what are we doing with mitigation? Well, mitigation is going to be a monitoring system to monitor these refrigerants that are mildly flammable, that have a little bit of potential of flammability. We're actually going to monitor these things and shut the system down if we have any significant refrigerant leaks. There's a variety of different things out there. I'll show you some pictures of what some of the residential systems are going to look like. I've got 2 manufacturers positively that are releasing what these are going to look like before the equipment gets out. It will look different on residential equipment versus commercial equipment in some applications, because some of the bigger stuff might need a more robust mitigation system. But all it's going to do is it's going to monitor the refrigerant, the leak of refrigerant, and then it gets to a certain limit, and it's going to go, hey, we got to do something about this. And when people first started hearing about mitigation, they got scared about, oh my, we're going to add new stuff. But I want us to stop and think about this for a second. Y'all work on gas furnaces here, right? Did you know that we already have mitigation built into gas furnaces? Okay, think about this just for a second. If I have a gas furnace, remember, a gas furnace is being supplied by an A3 highly flammable fuel. either natural gas or propane. Has the potential for combustion in the right environment. Has a lot of potential, actually. If we have, this is almost universal, if we have 3 failed ignition tries on a gas furnace, and what does it do? What is the mitigation that happens for that A3 flammable gas? What's the call that you get? Fan's just running. On a failed ignition, we know that there's potentially some A3 fuel in there. It could have a potential to ignite. Let's dissipate that crap real fast and let's get it out of there. Turn on a draft inducer and let's turn on a blower and let's mitigate these fumes. Let's just dissipate them as fast as possible. Mitigation simply means if there is any potential for combustion, I don't care what gas it is, if it's an A3, an A2, I don't care if there's a potential there, and we set a limit, we're just simply going to turn a fan on and we're going to dissipate that if there's that potential there. And so that's what you're going to see in residential systems, but you're actually not even going to see it on the small systems because there's not enough space for that to even happen. I'll show you that in a minute. It's kind of interesting. We are going to see a few components change in our systems when we talk about these mildly flammable refrigerants. We're going to see contactors that do not have open contact points. Why? What happens underneath them contact points when they go bad? They get hot or they spark. It's a potential ignition source. So if I had a leak at my outdoor unit, I'm just going to start eliminating any potential places for ignition. I'm going to do it with my motors too. I'm going to seal my motors up just a tad bit better so that there's no potential ignition sources on the motor. So we're really not changing the equipment a ton. We're just making it a tad bit safer. That's all we're doing. We're going to make sure if the compressor does not have a sealed plug on it, which almost all of them do today anyhow, if it doesn't have a sealed plug, you're going to see a sealed plug on your outdoor unit. If there's any kind of leak outside, we just make sure that we're not allowing any ignition sources. So that's really the 2 primary components. Now the indoor unit does get a little bit additional because we have to have a means to control the fan. So we got a couple ways we're going to look at that. So this is a manufacturer's diagram that I have intentionally replaced the parts on so that it is not the manufacturer's training material. It is a universal training material to show you what these systems are going to do. So what we're going to do is we're going to use some kind of a sensor. These are just 2 different brands. So depending on what brand of equipment you work on, you might see that one or you might see that one. It's just a sensor. It's all it's doing is just measuring. It's actually a 5-volt DC. Most of them that I've encountered so far are 5-volt DC sensor. So it's supplying voltage to it and it's sending back a variable voltage. And I'll show you what that looks like for a communicating system too. We're just going to read what's happening in the space. If it is a non-communicating system or if it's an existing system, how many times you change out a coil in an outdoor unit and leave the furnace in place? So can you retrofit an A2L system on an existing furnace? Well, sure you can. All we're doing is just making sure that we turn the blower on if we happen to have a leak. If it is a non-communicating system, we're going to see a separate board. That's your furnace board. Every furnace has got a furnace board on it. And usually we land our thermostat connections at the furnace board, right? Or the air handler board, where, traditionally, that's where we went. Well, we're just going to change things up a little bit when we talk about mitigation on residential systems, split systems. We're going to add this board. Remember, this is non-communicating. We're going to add a board onto the coil. It could be in the furnace. I've seen a couple models where they're actually putting the mitigation board in the furnace itself, and that's no big deal. Because if you walk up to a coil and you see a board on it, what's the first thought? Oh man, that's got an electronic expansion valve in it. This job just got harder. Some manufacturers are going to put this separate board in the furnace or air handler. Some of them are just going to give it as a kit and go put it wherever you want it. But here's the important part. What do we have to control? The fan, right? So what we do, really all of this mitigation board does, is instead of the thermostat controlling the fan directly at the furnace board, we're actually going to land our thermostat connections at the mitigation board so that the mitigation board is the first place that it stops at. On some of them, I'm telling you, this is a major manufacturer of equipment. It's not in this room, but it's a major manufacturer of equipment. This is what they're doing. They're using their existing furnace board, so whatever it is. It would be a new piece of equipment or existing piece of equipment. We're just simply going to, with that new A coil, have a mitigation board. We're going to move our thermostat wires from the furnace over to the mitigation board so that if the sensor, and I've got 2 different sensors on here, but most of them really only have 1 sensor. This is just to show you a couple of different kinds that you could potentially see depending on what your brand is. And so all it does, if that sensor hits its limit, it's going to go, hey, there's a problem here. And what's it going to do? So what's the call going to be from your customer? Fan's running and my air conditioner's not. Or fan's running and my heat pump's not if it's a dual fuel system, right? It might take them a couple months before they notice their electric bills are not using much as energy and they go, oh, The furnace has been running this whole time. Must be something wrong with my heat pump. Unless the fan is just sitting there running, and then it's just going to go, my fan never shuts off. And you're going to show up and you're going to take a look at it. So there's your non-communicating or your existing system. We're just adding a board with a sensor to go, hey, if we have a leak of refrigerant and we get to a certain limit, there's a problem. You need to have a certified HVAC contractor come out and take a look at this thing. And just so that you know that something's wrong, we're just going to turn the fan on all the time. We might shut the piece of equipment down, but if it's in heating mode, we're probably not, because we don't want you to freeze, but we want you to know that your blower's running all the time. This is going to be a very, very common application. Another brand is doing this. They're putting a sensor, it's a different looking sensor, but it does the exact same thing. They're going to put a sensor and they're going to send a module so that you can attach the module to the coil. You can attach the module in the furnace, side of the furnace, put it wherever you want. But it's the exact same principle. It's just going to add on a separate board to do that work. So same principle as the first slide that I showed you. You bring your thermostat wires over to your mitigation board, and mitigation board goes to the furnace. So I was having a conversation with a OEM trainer about that sensor. So that sensor is a 5-volt DC sensor. And I said, well, what about a communicating system? Can't you just bring that in? Because if you didn't know, on any inverters, any piece of equipment that you work on that is communicating, that's got pressure transducers or temperature thermistors, all of those inputs actually run on, I wouldn't say all, most of those inputs run on 5 volts DC. So like a pressure transducer, we send 5 volts DC to it, so it's got ground or common, it's got 5 volts hot, and coming back is a variable 5 volt DC voltage. And that's what our board looks at for an input. I said, so what about using that 5 volt DC on like a communicating system? Because even our communicating thermostats are typically run on a 5 volt DC platform. If it's a communicating furnace, a new communicating furnace or communicating air handler, all we actually did was just took the sensor and we added an extra input plug on the board so that we can just take the one sensor and literally plug it into the board of the furnace or the air handler, and you don't even have a mitigation board. Because you're right, what happens if it's a variable speed system and it's a communicating system? It's just going to ramp the fan up to 100%, so the homeowner goes, well, that's weird, usually my fan is only running like 30 or 40% in off cycle, but for some reason for the last week it's been running at 100%. I better call my contractor. Now I don't know what error codes are going to look like, because what happens if you get an error code for an open limit on a gas furnace on a communicating system? It depends on the manufacturer what they're going to tell the homeowner. It might say open limit, contact your contractor. It might actually say open limit. It might not even say that. It might just say contact your local service provider. So that part, the communicating side, I've not seen any of the manufacturers show what that looks like yet. So that one's still to come, but I'll be able to tell you in the next few months what that's going to look like when I see my first pieces of equipment. Non-communicating, you have a separate board that is a mitigation board that just simply brings the fan on. It might even shut the system down if it's in cooling mode. Because what better way to tell a homeowner that you got a problem? Because they're cooling off and turn the fan on in the middle of summer. They're going to call you. And so that was the intent. It's not to scare anyone. They're not going to get an error code that pops up, oh, you got flammable gas, No, it's going to say there's something that ought to be looked at. Just like a regular leak in a system, if it was a A1 refrigerant. Eventually, they're going to call you because they're just uncomfortable. Their comfort is not the same as it was. And so that's kind of what we'll see with this, right? So that's your primary things you're going to see for A2L mitigation. So that same ASHRAE 15.2 also says, well, what if it's not a lot of refrigerant? Is it really that big of a deal anyhow? And so they actually did a lot of measurements and they did validation of the combustion of the refrigerants, and they determined, well, you know, it depends on the refrigerant because every refrigerant burns differently, and it depends on the amount of space that it's in. So let's re-look at all of this, and they came up with some different standards. They call them M1, M2, and M3. Don't get them confused with air flow standards used for blowers. It's just, M just means measurement. So it's a different table that ASHRAE came up with, and they said, you know what, let's relook at this because maybe not every system requires mitigation. And so what they concluded with that, and this is what you're going to see, based on those two refrigerants, R32 and R54B, R454B, if it is 3.9 pounds of refrigerant, if it's less than that, it's not even going to have mitigation. If it's 4.1 pounds of 32, it's the same thing. So that means 1-to-1 mini splits, less than, let's just say roughly 4 pounds, because it depends on the refrigerant, but roughly 4 pounds. Less than 4 pounds, it's not even going to require mitigation. Not at all. So it changes the way we look at it, because we were starting to worry that, is everything going to have mitigation on? Is every new piece of equipment going to have all these new controls? And what we find is no, it actually doesn't. So that's going to be the barrier, 3.9 pounds for R454, 4.1 for R32. And a maximum charge limit that's it's around 34 pounds, I think it's 33.9 for 454 and 34, like 2 or 3 for R32. And so a piece of equipment can only be designed for that M1 or M2 for residential. You're going to be below 4 pounds and you're going to have nothing, and your world is not going to look any different, or you're going to be above 4 pounds and it's going to look a little bit different. That's pretty much it, all right? That's what you're going to see for equipment-wise. If you get a system, split system, it's got more than 4 pounds in it, and it's got a separate box and sensor that comes with the thing, now you're going to know where to put that thing. Once you read the installation manual, it's going to tell you exactly. But this is going to be every manufacturer, and there's going to be a lot of installers calling. So these are factory charge standards. But let's talk about, because the equipment's either going to come with it or not. Remember, this is all supplied by the manufacturer. If it doesn't come with the equipment, you're not putting it on. If it comes with equipment, you're putting it on. So it's going to be model specific. But if you think about it, when's the last time you installed a heat pump that had less than 4 pounds of refrigerant in it? Residential split system. So it really comes down to window shakers, wall huggers are probably not going to have any kind of mitigation. Residential split systems, you're probably going to have mitigation on them. Light commercial, you're going to have some mitigation on them. And the controls are going to be very similar until you get into some of the heavier commercial. And if you think about it, it's kind of the same thing. You get into a heavy piece of commercial equipment, it's got bigger, heavier, more robust components in it, just because there's different building codes that applies to those. But for most of us, residential, light commercial, that's all you're going to see. Just think logically. If we're installing a new A2L system, what does a plumber do when they have a water line going through a stud? They make sure that the picture hanger doesn't run a screw or nail through it. They put a plate over it. It's going to be recommended by your manufacturers that if you're running a line set through a wall, that we make sure that we put a steel plate over it. We're going to secure it. That's all we're going to do. We're going to eliminate the potential for leaks just a little bit better. Our manufacturers of tools have been way ahead of the manufacturers of equipment preparing for this. Some of them have already rated their equipment for A3, highly flammable stuff, even though they didn't have to. So a lot of your tools are actually going to be rated. Just want to make sure that it is. Proper evacuation, more important than ever. System charging, absolutely critical. You might see a change. We're kind of in debate in the manufacturers of whether they're going to have left-handed threaded refrigerant cylinders. So you probably are going to see that, which means you might want to get a separate set of manifold gauges or hoses when you're working with A2L installations. It's no different than if I personally had an R22 manifold set and an R410A manifold set when I was doing residential installations, because one had mineral oil and one had POE oil. It's no different with this. I'm going to have an R410A system and a set of gauges, and I have an A2L set of gauges. System repairs, make sure any electrical components that we put into that system is what came out of that system. We're not going to take out a intrinsically safe motor, which means it won't spark, and put in some kind of a aftermarket motor that could, if we're doing a repair. That's years down the road, I know, but just making sure that you're aware of that. So that's what our intrinsically safe motors. When we talk about standard 34, this is how we actually measure all these refrigerants. If you want to see these in action, we've got some really good videos. It's part of that training that covers that. And all it does is just looks at that propagation of them. So if it's a class 1, it's going to be within a certain range. A2L gets slightly out of it. A3 just absolutely fills it up. And Opteon did a neat little video for us that shows what these different classifications of refrigerants will look like inside of their test chamber. So they will, in a sealed environment, introduce refrigerants and then put an ignition source into it and then measure it. There's that 90 degrees. So they're just measuring how far the flame can move. So there's what 1234YF, it's in our car. It actually has some flammability. That's why it's an A2L versus that R290. I like to burn stuff, but I wanted to do this to show you what it actually looks like for refrigerants based on a silicon nitride igniter, a silicon carbide igniter. This is 1234YF, this is A2L. This is what's in our car, this is what's being blended with R32 to make 454. In its vapor state, there is zero propagation with a silicon nitride, a silicon carbide, or a direct spark ignition. I just want to see what it looks like in my world, right? If I have a leak inside of a furnace, what's it going to look like? Nothing. Not even in vapor state, you'll see a tad bit in that cone, but here's the only potential for ignition in any refrigerant, A1, 2, 2L, or 3. If we are converting from a liquid to a vapor. We're changing state. We change the potential for combustion, and we can have some flame. It's not a ton. It has to be the exact right circumstance, and it's really more apparent when we're working with an actual open flame that is a continuous open flame. And so you'll get a little bit, but it's really not a lot to do much of anything. That's the reason we add these mitigation. What's the chance of it actually ever doing any kind of damage in a real-world scenario? It's almost none. But because there was a little bit, we decided to adapt our equipment to compensate for that. And so that's all that you're going to see. We're going to see that change. We're going to see the change from just a disc that ruptures and releases everything to a disc that is spring-loaded, which means we are going to probably have to change the way we transport some of our refrigerants. If your refrigerants are in a horizontal rack, that means that actually should be stored in the upright position. We'll talk about that as the DOT gets a little bit more involved. So right now, we just have to make sure if it's stored, if a tank of an A2L is stored in a vehicle, that check must be in the upright vertical position before. It's very possible. Just be thinking ahead. What am I going to give? What floor space am I going to give up if I have to? So to be aware of that, you're going to see the cylinders a little bit different. So we're going to have separate recovery cylinders for A2Ls. We already have A2Ls being returned back to Johnstone Supplies. So they're going to be gray still, but they're going to have a red band on them, and they're going to be designed specifically for our A2Ls. R32, even in itself, has actually been sold here at Johnstone Supply for quite a few years, because of the R32 window shakers that are out there. And there actually are a lot of ductless systems that are being sold on Amazon, which I completely disagree with, but it happens, that are R32, which means the potential for you to run into a R32 mini split that a homeowner has installed or some other contractor has installed can happen. So you need to be aware of this, that there are R32 systems out there. R454B just got released in refrigerant cylinders, so that will be available. So R454B is already waiting for your first installs of equipment, which should be out in the next few months, very realistically. But we don't know what that exact date looks like. No one really does. Some of them went ahead and converted their lines because of SEER 2. They went ahead and just reconverted their lines over so that every piece of equipment coming out is already capable of running R32. The last time you went to a hardware store, say Lowe's or wherever, and you switched out your tank of A3 gas, where was it at? It was in a ventilated box sitting outside of the building. And so you might start thinking about that as a distributor, even if you're storing new cylinders in your warehouse at your shop. Building codes might ask you to put in a sprinkler system, or you might ask them if you can put it in a ventilated locked box sitting outside. And they're going to probably say, "Huh, that's a great idea. Glad somebody thought of that." Right? We've had refrigerant and combustible detectors for a long time, so it's not really new. It's just something that is new to many of us in the residential industry. You want to learn more? Make sure to stay up to date with AHRI. That's any changes that come. They have updated a lot and give better resources on how contractors can adapt to this. And the technology transition rule, the EPA now is becoming even more powerful than the Kigali Amendment and the AIM Act in the way that we reduce HFCs. There's a whole bunch on that. If we want to learn more about it, we go to the technology transition rule. You're going to see this sticker on the equipment as well, showing on HFC equipment, showing that it does have, so R32 and 454B. You're going to see a new sticker on the outdoor unit that will say that it has a fluorinated gas. That is our biggest things, is that January 1st of 2025, that's really going to make an impact on what refrigerants go into new equipment. Here's where our GWPs come from. This is actually in our EPA presentation, where we talk about the ozone depleting potential and the global warming potential of our primary refrigerants. And as you can see, as our R410A has a global warming potential of 2,090, whereas R22 actually had a global warming potential of 1,810. So our R410A actually has more global warming potential than R22. We had to make a change. We're going to be looking at these less than 700 GWP refrigerants going forward. And there's not a lot. I'll be honest with you. Going forward, there's not a lot of refrigerants that are available right now. Your primary ones are R454B. They're at 466. and our R32 at $677. As of right now, the only refrigerants we're going to see in new residential and light commercial are going to be R32 and 454. It's the only ones that fit the bill, and they are both A2Ls. There is one other piece, and I'm going to leave this up here because there's going to be some changes coming to requirements for training. We expected it to happen in this technology transition rule. It didn't. They postponed it. They want input from our industry. The EPA is looking for recommendations from the industry for what is going to be a potential requirement for going through a low GWP training program for all technicians. I might be encouraging you to do it now so you're already prepared for it. You're not doing it at the last minute. I appreciate all of you being here. I hope you learned a little bit, and we're glad that Johnstone Supply is stepping up the initiative to train an industry and keep us all prepared for the things that are coming in a short period of time. If you think about it, no matter what, in just over a year, every one of you are going to be working with R32 or R454 in new equipment. Likely it's going to be before that.